Okay, so chapter one, lesson one's just all about kind of a review of all the stuff from algebra 2, and pre-calc. So just making sure that you've got all that solid. One of the things, there's sometimes different terminology. They use increment to mean change. Remember, your delta is just change, and we just take one value minus the other. Okay. So say that we want to find the change in x and the change in y. To do our change in x, we just take 4 minus 1 to get 3. Change in y, 5 minus -3. Watch your negatives, that always gets people. To get 8. All right. As a diver descends below sea level, so you're just doing, it's just more of a word problem type thing, but the same thing. A diver descends below sea level from a depth of D1, 20 meters to D2, 25. The pressure increases, so descends going down, increases, so watch your terminology there, from P1 and P2 atmospheres. All right, so what are the increments in depth? Our change in D is 25 minus 20. And when there's labels, make sure that you label your stuff. Change in P are 3.485 minus 2.988 to get 0.497 atmospheres. All right, so here's some definitions. If you need to pause this to get the definitions copied, try and always copy that makes sense. If you need to do word for word, that's fine. If you need to just kind of get the gist of it, that's fine. These are your notes. So your variable y is a linear function of x. Y is a function of x if the ratio of the increments of y, change in y over change in x, is constant. So that's your slope. If there's a constant slope, it's linear, which then leads us right into slope. If you have 2 points of a graph, the slope m is of the line is the ratio of the increments. We've talked about rise over run before a lot. Change in y over change in x. So y2 minus y1 over x2 minus x1 should be very familiar. All right, so using slope to find a coordinate. All right, so if we have a point, we know the slope. Find the y coordinate on the line that has the x coordinate 3.6. All right, so we know this is the formula. We're just going to plug stuff in. All right, so we're looking for the y coordinate. We know the slope is -2. We're looking for y2 minus the y1 is 3 all over x2, 3.6 minus x1, 2. All right, so that leads us to, if we simplify this, we can subtract the denominator. Then multiply both sides. Now, I would always recommend, if you're doing a decimal, putting a 0 in front so that your decimal is seen, and so you have an accurate answer. So just using your formulas, manipulating your way through to find your missing unknown. All right, example 3. The pressure P on a diver is a linear function. That's important. We know the pressure P is 20. No. We know the pressures at 20 is, sorry, the pressure is that, and the depth is 20. Sorry. An increase of 5 meters in depth so if our change in depth is 5, we get a change in pressure of 0.497. Increase of 5, positive depth, increase of pressure, positive pressure. Find the pressure at 23, 42, and 16. All right, so first of all, this here allows us to find our slope. All right, so we can do our change in pressure over our change in depth. It's not a decimal. Careful. So we get a slope of 0.9. If you get a non-ending decimal, always go 4 decimal places. You will be always, all answers will be expected to be correct to 3 decimals. So if you always go 4, you know you're going to be good. All right. So then we're going to do the same thing that we did up here. Let me make some. All right. So here's our slope of 0.0994. We're looking for P2 minus our pressure of 2.988. And we're looking at it when it's 23 meters, and this is when the depth is 20. So this is 3. Multiply both sides by 3 and solve for our P2. Doing your math. You should get the first P2 at depth 23 meters to be this. All right, so finding it for 42 and 16 is just going right back through, doing the same formula, only plugging in 42 here and then 16 and solving for P2. So that's just a little monotonous, so we're not going to finish that out. All right, so it says using the information in example 3. I'll put that back up there. Find the linear equation as a function of D. All right, so we know we found our slope earlier of this from up in example 3. So we're just going to use our general, I'll go P minus, we're going to use the point pressure minus 2.988 over depth minus 20. That will equal the slope. So all of this is just using the slope formula and manipulating it. All right, so I need to get all of this out of the denominator, so I'm going to multiply both sides by D minus 20. distribute this. All right, hang on a second. I didn't show my work, so I'm gonna leave this like this. Add this to the other side. So P as a function of D. Oops. When you distribute and put it all together, you get this equation. Okay, so I think it's always a little more annoying when you've got all these decimals, but that's your real world stuff, and you're going to see a lot of that this year. This is your pretty generic point slope. You should be very familiar with this. You've got this equation, y minus y1. I'm hoping you're very comfortable with that, okay? I would just say leave it. You don't need to do this. They just moved over the y1 to the other side. All right, so first example of this one, much more straightforward. Y minus your y coordinate equals your slope times x minus your x. Now, I'm going to be really picky about this. You're done. Do not solve for y unless it asks you to. This says find the point slope equation. You're done. Leave it alone. Because if you solve for y and you do it incorrectly, you don't get any credit. Here's your slope intercept, y equals mx plus b, probably the one you're most familiar with. Your general or standard form, ax plus by equals c. You don't need to write every single thing down, just your general stuff, okay? Parallel and perpendicular, this looks all complicated. I think the big thing I want you to know, what do we know about all parallel lines? They have the same slope. This is numerically perpendicular. And oftentimes we use an upside down T to represent perpendicular. Has opposite reciprocal slopes. You're going to be doing these all the way through the year. Okay. All right, so these are all just doing all the different equations. If it does not specify what type of equation, you can do any equation that works. Here we have a point and we want it parallel. Keyword to parallel means same slope. What's the slope of this line? 2, so the same slope. We have a point, we have a slope, we're going to use point slope form. Y minus 5 equals 2 times x minus 3. Done. Leave it alone. B. X intercept of 6. Anytime they're giving you an intercept, they're giving you a coordinate point because the other coordinate point is 0. The x is 6, the y is 0. Perpendicular. All right, so we first need to determine what the slope is of this line. So I'm going to get y by itself. So my slope of this line is -2, and my perpendicular slope is +1/2. All right, so I'm going to use this point and this slope, y minus 0 equals 1/2 times x minus 6. Done. Leave it alone. Opposite reciprocal. All right, let me get rid of this. Anytime you have to pause it or go back, do what you need to do. All right. All right. perpendicular bisector with these endpoints. So think of just anytime you need to sketch out your information to get a better understanding, it doesn't even need to be accurate. So 2, 3, say, is here, 6, 17 is up here. If we connect those 2 points, what's key for the perpendicular bisector? It's going to, first of all, cut it in half and then be perpendicular. All right, so we have to find the midpoint. That'll be the point we're going to use for that line. The midpoint of these 2 points here, halfway between. So what's the middle of 2 and 6? 2 plus 6 is 8, divided by 2 is 4. Just find the average when you're finding the middle. 3 plus 17 is 20, divided by 2 is 10. So this ends up being this point that we're going to use for our point slope. Now, we're going to find the slope of these 2 points. So just our y minus our y over x minus our x. So we get 7 halves, all right? But we want it perpendicular, so our perpendicular slope is the opposite reciprocal. So here's our slope, here's our point. So for letter C, y minus 10 equals negative 7 halves x minus 4. Okay, there's example 6. Get what you need, then we're going to move on. Oh, in example 7, now that we've got all this up, is just matching it. So, you know, we might, what I'd recommend is maybe turning off the video, seeing if you can do your matches. What will this one turn into? How do you manipulate these 3 equations and see which one this matches? So this has x and y both on the same side. You might want to, you have a lot of options. You can get y by itself and you get all of these y by themselves, and then match. All right. And then if you want to turn it back on when you're ready, this should be, how do I have this? This is 6b. This is also 6b. This is 6a. And this is 6c. All right, so just kind of play around with that. All right, so you see this a lot where you convert different things. And especially if you, I would say if you had Mr. Wallace, you might have done this in physics, something like that. It says find the linear equations for converting Celsius to Fahrenheit and Fahrenheit to Celsius. All right, so we need to remember that when we're boiling water, all right, so first of all, let's think, I want to find our Celsius value and our Fahrenheit value. Boiling water for Celsius is 100, and for Fahrenheit it's 212. For freezing, this is where metric's kind of nice. Boiling's 100, freezing is 0. And then we get these weird numbers in English. Fahrenheit, 212 for boiling, 32 for freezing. Okay. And we just find our slope. So we do our y minus our y over x minus x. Simplify it all down. and get 9/5. Okay. So notice when, for freezing, this is our y-intercept. So if we know our y-intercept, we can actually just do y equals mx plus b. And what does y represent again? That's Fahrenheit equals 9/5 Celsius. Oh, sorry, we know B is the whole point. I was just talking there. Okay, so that's in terms of our Fahrenheit. And then you can solve it for Celsius, but that works. All right, so then it says convert 20 degrees Celsius to Fahrenheit. So we just plug in. Let me make a little room here. So if this is our Celsius, we'll plug it in for Celsius. Do your math. 68 degrees Fahrenheit. Okay. All right. You're going to do the same thing for 95 degrees Fahrenheit. So multiply both sides by the reciprocal. All right, so you're just plugging values in for each of the variables and solving for the missing. Okay. All right, last but not least, solving simultaneously. That's just a way of how can we solve when you have two different variables and two equations. How do we solve for that? You've got lots of options. All right, you could do substitution, elimination. We did matrices last year. You can graph. I would say the way this is set up, that using elimination or linear combination is your best bet. So we want to either eliminate the x or eliminate the y. I notice the y's are already opposite in sign. So I'm going to multiply this by 3 and this one by 5. So distribute 3 all the way through. Then distribute 5 all the way through. Then we're just going to add our columns, our like terms together, hence eliminating our y's. As soon as we know our x value is 8, we can plug x back to either equation to solve for y. So what this tells us, this is the unique pair, x and y, 8, -3, that when you plug it into each of these equations, makes both true at the same time. Graphically, if we graph both those two equations on a graph, they would intersect at the coordinate point 8, -3.